That's really dumb. Okay, now we're live. I was like, oh wow, I found a tricky way so that I don't forget. How annoying. Okay, we're live. Don't worry. Camera pointed at the screen, doesn't see you. No worries about privacy violations or anything like that. Quick fun story. Last year when we came back to school and I started doing this, and I had to go to the office for something. It was my honors algebra 2 class, so I got a volunteer, and we were doing this investigating functions, but we'd been doing it for a while, so they sort of knew the process, and I got a volunteer to come up and just write down on the board everything from the investigation. And she was just doing exactly what I'd done, pull a name, blah, 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 do the investigation. I went to the office, I came back, I let her finish. And then after school was over, I realized, oh no, I just had one of my students on YouTube on a live stream for 15 minutes. Totally not allowed to do. So I had to very quickly go and edit the video to get rid of the 15 minutes where she was, which was disappointing because she did an awesome job. Desmos.com. Are you there? Everybody say yes.
Yes.
If you're not there, then just lie and quickly go there. Math tools. Graphing calculator. Oh, it's not showing.
It says enter code.
What? It shouldn't. It should just look like. Check with your partner. Make sure that's what you got. Cool. I'm going to give each pair an equation. So you're going to type in the equation. You type in equations right up here. Let me demo this for you. Y equals 2x. I'm going to type in the one from the warm-up. I need to do a squared. You guys know what a squared symbol looks like? It is officially called a caret. Or caret with an E, I forget. Caret with an E, I think. Does it matter? No, totally not. I'm going to call it a caret with an E. You probably found it, seen it on your calculators. It's off to the side. So on the keyboard, it's above the 6. And it will just put the cursor up so that you can type in what you need to type in. And now to get out of there, and this is going to be important on some of the things you guys are doing too, to get out of the exponent, because I want to type more, but I don't want it up in the exponent, I just arrow to the right one, and it'll just move over and go back down. And now I can put in the +3, and boom, there's the graph of the equation that we were looking at during warm-ups. All right? Now, you can't break it. And that's not a challenge. I'm just telling you, you can't break it. If you completely mess it up, close the tab, open a new tab, type your equation back in. If you get it so that you just can't see it or you feel like you just close the tab, open a new tab, type in Desmos.com, go to graphing calculator, type in your equation again. Here's how you do a square root. There is, bottom corner, right down there, a little keyboard thing. Everybody click on it. Bottom left corner, click on the keyboard. Brings up a keyboard. Notice that there's also some shortcuts for things like a squared, a to the some number, if you're using something other than a squared. There's a square root symbol. There's also buttons over here called function. If you click on the function button, everybody click on the functions button. And it will bring up even more stuff because we're going to be using a lot of, well, we're not going to use any of those. Just ignore that. But there's more stuff over here. Okay? The goal today is to figure out how to use Desmos to find information about an equation. I'm going to give you an equation. I'm going to hand you out a slip, one for each pair. And here's what I want you to find. As many different useful or interesting pieces of information. I'm not going to tell you what to look for. I'm going to tell you that I want you to just find as much as you can out about the equation that I give you. You're going to be talking to your partner a lot. I expect to hear conversations. I expect you to be digging around, looking at this, looking at your graph. You can make a table by clicking on that little gear window or gear icon up there. It'll give you an option to make a table for your graph. I want you to come up with as much interesting information as possible. I'm going to start after I give you your equation by giving you about 10 minutes to type it in and talk. We will then brainstorm. What kinds of things did you find? And then I'll give you another 10 minutes to go back and find some of the things that other teams found that you didn't find. Okay? So, let's start with the awkward fact that I didn't actually get around to cutting these up. So I'm going to be walking around to your table and cutting them up as we go. Fortunately, faster, so it'll be all right. So 1, 2, 3. Okay. You guys get that one. You guys get that one. You guys get that one. You guys get that. You guys get this. Wait for it. Wait for it. What? You guys get this one. You get that. You guys have one? Nope. You get this. Who doesn't have one? You guys don't have one either? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I have one in my hand. Ha! There, you guys get that one. Everybody's got a function? Here's what I want you to do, guys. Take notes in your notebook. Write down your function. Start writing down everything you find about it as you work through Desmos. 10 minutes. You guys met Mr. Tomato? Mr. Tomato keeps time for me. He will tell us when 10 minutes are up. Go. No, they were. No, you just need the one I gave you. Uh-oh. Uh-oh. This does not look like that. It looks different.
Oh, this is under the.
Yeah, there you go. Arrow to the right. There you go. Now type it. And see, now you're out of the square root. Good. All right, let's go. Should your notebook be open?
Oh, what do we just write that?
Oh my gosh. Really? How about your partner? Chase? Exactly. Look, I even wrote it on the board for people who didn't hear. Goal, as many different useful or interesting pieces of information as you can find. All right, looks good. Oops, sorry. Looks good. If you put y equals in front, you'll get the exact same graph, but it's easier to make a table if you got a y equals there because it'll make the table x and y for you, and it won't if you don't put the y. Looks good. All right. Looks exactly the same as Emily's, so I would say it sort of has to be. She just sees it differently. All right, remember, as many different useful or interesting pieces of information about your graph as you can. Don't forget, you can put your fingers on the screen and go like this, and it'll get bigger and smaller. Crazy, man.
I don't know, you can expand it.
Also, if you decide you want to go back to the original because you've been expanding it and you messed it up, there's a little button that looks like a house over to the right. It's only there if you've been playing with it, but then you click the house, it'll go back home again, which is where you started. Uh-oh, that doesn't look like what's on your little piece of paper. That equation doesn't look like what's on your little piece of paper.
What?
It's different from both. You got the same equation. You've done a nice job of having the exact same equation. Means that you're both on it. Still quite different. What do you see? Look at that minus one. What do you see?
Description.
You see it? Look at the piece of paper.
Well, it's starting point.
Where's the minus one? Oh. So what you gotta do is get rid of that, get rid of the whole minus one, just backspace past it. Now arrow to the right.
Yeah, X and Y is that.
Just arrow to the right, and then type minus one. Just arrow. Now type minus one. Now you have set the reasons. Cool? It is, yes, well done. It's okay. It was a long summer.
Like,
Not a bad idea. It doesn't have to be really accurate graph, but maybe a sketch, just so you get the general shape and where on the axis it is.
I wanted to try golf,
Yeah. Hey, let me get different graphs. Or you just zoom differently. Oh, I see. You're up to 1,000. Gotcha. Okay. So, writing stuff down, interesting observations, cool.
I think we have everything.
Cool. You're talking to him about it?
Yep.
3/2. I don't know what that means. Oh, gotcha. Remember how we draw coordinate points, put them in parentheses, put common, you know?
Yeah, guess so.
Yeah.
Did you say good?
Since he's not talking to you, you wouldn't even have heard that, right?
Nope.
There you go.
I did.
Oh, man.
I thought you broke off.
Wow, you broke the cover that's designed to be unbreakable?
It's only a little piece.
Actually, did it break or did it just snap? All right, will it snap back on without that piece?
Oh,
I'll just
I
figure
still
out
get
what
that.
the-
There's still yeah.
I wanna know.
That's Spanish.
Did that just do that when you're trying to like fold it over backwards?
No, I was trying to do
Oh,
this
so
is
lucky.
drawing soy sauce.
Oh, okay, okay, good to know. I'll get dry soy sauce on mine. How many teams are still working on stuff with their graphs? Can I stop a little bit early and we'll talk about what kinds of things we have? Let's do it. Aaliyah, give me a thing that you guys found.
I found an obvious thing. It was like when you turn it from like not having a table, there's like different points that you can find that
Okay, but I need something. I mean, what should I write down? What exactly were you looking at that you thought was interesting?
like when it's not in table form, it's just
Okay, so
like there's more than just like the two that because there was two originally and then I switched it to
so you're saying that when you add the table, it adds points?
yeah, it was weird.
Okay. Interesting. Okay. Now, I would say, and this isn't a knock on Aaliyah and Jonathan, but that's not an interesting piece of information about your function. That's an interesting piece of information about how Desmos works. But this is good because we haven't really used Desmos before, I'm guessing, at least not to do this. So we're finding stuff out. Dylan, an interesting or useful piece of data or information that you guys found out about your we're busy. Oh, Dylan's not here. He's absent right now. Andrew.
For ours, it curves pretty heavily.
Here's an interesting question, Andrew. Which direction does it curve? Which way is the curve? Is it down
Down
or
left,
is it up?
down left.
Did anybody have one that curves up? Show of hands if yours curved up instead of down. You guys did? You guys did?
Oh.
Okay, curved. So curved down looks like this. Curve up looks like that. Okay. Guys, we're going to come back later and we're going to talk about some mathematical language that we can use for what direction that curve is, whether it's up or whether it's down. So we'll come back to that later. Cool. Thank you, Andrew. Oh, George is not here today. Eliana, something you guys found out.
starts at 4.
seems like an important point, right there. There's the point. It starts and it just goes off from there. I'm not gonna write down your specific numbers, because of course that's gonna be different for everybody, maybe. But starts at, good. Lisa, you got another one?
Oh, it goes through the X's. No, why?
Did yours go through both? X and the Y, or just through one of them? Okay. Anybody have one that went through both? Show of hands. Got one team here, went through both, went through both, went through both. Anybody have one that didn't go through either of the axes? Show of hands. Started somewhere and then just went whizzing off? No? I don't know. Made up equations and handed me. I haven't actually looked at them. Cool. Casey,
Alright.
got another one?
So ours, like, it's a downward slope, but it stops gradually getting further along the x-axis at a certain point.
So it stops. Does it stop in the other direction?
No.
Okay. So yours is going down.
Not that I can see.
You said it was going down.
Or, yeah, it is going down.
Okay.
It-
And then it stopped at some point. So I'm going to say that the place that it stopped is probably just what Eliana had said, that she had a starting point, but it just depends on which way you're looking at it. Is it a starting point or is it a stopping point? What's the other possibility? Theirs is going down. What else could it be doing instead of going down? Anybody have one that's not going down? Really? Which direction are we going when we talk about something going down? Are we going left or are we going right, or does it not matter? Which direction do we read across a page? Left to right. Guys, this is going to be exactly the same thing. As we move from left to right, if your graph is getting lower, then it's going down. As we move from left to right, if your graph is getting higher, it's going up. This is always from left to right. Because that's the way we read. We start at the left and we move to the right and we see what it does. I want you to take 2 minutes. I want you to talk to your partner, and I want you to make sure that you have all 4 of those pieces of information. Have you written down whether it's curving down or curving up? Have you written down that starting point? Have you written down the X and the Y intercepts if it has them? Or you've said none if it doesn't. And you've written down whether it's going down or whether it is going up. Go. Talk to your partner.
Yeah, pretty much.
It's going down. Yeah, why? Oh, I wrote it down. So you look at it.
The X intercept is crouched.
Yes. You may. Sign out and in on the sheet, please. Guys, did I tell you about bathrooms?
Nope.
Okay, you should know this. If you have to go to the bathroom, I'm a big fan of your going to the bathroom. I don't want you sitting here for 80 minutes dying because you didn't think you could go to the bathroom because it's school. No. You guys are old enough that if you need to go to the bathroom, here's what I'd like you to do. Put up your hand, let me know you guys go to the bathroom. 99 times out of 100, I'll say, no problem. Every once in a while, if I'm right in the middle of something super important, I may say, can you wait like 2 minutes? If the answer is no, that's okay too. All right? I will get you to sign that in. They've asked us to do this. I think part of that is just because, for example, if we had a fire alarm right now, it's good for me to know that one of my students left and went to the bathroom, because when we get outside, I can say, hey, I had a student in the bathroom, and then maybe he comes and finds us, or maybe they go find him. So make sure you sign in or out. But yeah, don't feel like you can't go to the bathroom because we're doing math. All right? Questions about that? Awesome. Okay. Math vocabulary. You should be writing this down. You should have your highlighter out and ready to go, because I am going to have you highlight this. How many people have a highlighter? Show of hands. I see one in that group. Group.
Yeah.
Either you got highlighters? Yes. Excellent. You got highlighters? Good. You got highlighters over there? Do you guys have highlighters? What? Okay, good. Every group has access to a highlighter. I will tell you what I want you to highlight. But this is one of the reasons that we work in notebooks, is because I'm going to have you highlight stuff, and that way when you don't remember, you can just go flip, and find the thing you highlighted, and oh yeah, there it is. Curve down, curve up. Let's talk about this one first. We are going to use the word concave down or concave up. How do you remember which is which? Something that is concave looks like a cave. What does a cave look like? It's a hole in the rock. So the cave part is the side that would be the hole in the rock. When I look at these, this is concave down, because the cave part is facing down. This is concave up, because the cave part is facing up. There's only two possibilities. Curves are going to be either concave up or concave down, or they're not going to be concave at all. Anyone know the word for a... Oh, see, I can't even ask you the question without giving it away. It's a line. You know there's no such thing as a curved line, right? Lines are by definition straight. So if somebody says to you curved lines, just shake your head and walk away. Down or concave up. We are going to use this as part of our description. We'll talk about that a little bit later. Concave down or concave up. Starting point, pretty obvious. We don't need vocabulary for that. X-intercept, Y-intercept, just a quick refresher because it was a long summer. This is the X-axis, and this is the Y-axis. How do you remember? I have no idea. You just need to remember. I've never seen a good memory device for which is which. X, Y. One thing you might think about is that the X-axis looks like a number line. And that's really what it is. I mean, well, yeah, it confused the issue. But if you think about number lines, all you're doing when you make a graph is you're adding a second coordinate to your number line. Okay? Going down versus going up. Thing to remember first off, don't forget it's always left to right, just like you read. Does it get higher or does it get lower? The words we're going to use are increasing and decreasing. Increasing and decreasing. So when you were describing your graph, you might say, my graph Thank you, Robin. Aaliyah, you. I guess you're leaving. I'm not 100% sure because it says immediately see Mrs. Brinkman in the office, but sign out when you leave. So I guess that means leaving. Confusing note. So a description of your graph might be concave up increasing. If you say to me, Mr. Ermerding, my graph is concave up increasing, I know that it looks like that. Except not that part. Notice this is concave up, and it is increasing as I move from left to right. I know exactly what your graph looks like. Now, I don't know how steep it is, I don't know how flat it is, but I know that it has to look like that curve right there. Concave up increasing can't look anything but like that. Questions? Stretch. Cool. Oh, just the back page, bottom tray. Any questions? I want you to take a highlighter and I want you to put a box around this. Highlighter in a box. My highlighter doesn't show very well anymore. It's just a yellow dry erase pen. Running out of enthusiasm for being a yellow dry erase pen. Yeah, it doesn't really help. Let's talk about, yes. You want to hear a fun fact? This is what I was going to do with you tomorrow. I was just looking at this and I thought, oh, that's odd. How come I haven't done this with the other group? Oh, so we're switching lessons. Oh, well. Doesn't matter. It really makes no difference. It's just sort of two different things. This is sort of an interesting thing. Let's talk about domain and range. That's why I paused and looked confused there for a bit, but you couldn't see it because my confused face was carefully hidden behind a mask. I planned that 2 years in advance. You know, if I could get them to make me wear a mask all the time, you guys wouldn't know when I was confused because it would be hidden. Domain and range. You've seen this before, so I'm going to just take a couple minutes to refresh and to remind. Some people have trouble with this. And so I just want to make sure that we're comfortable. Guys, domain, I'm going to give you a definition and then I'm going to show you an example on to write down. So go ahead and write down the word domain. We're going to just start with a definition. All possible input values to an equation. We're going to start by just talking about what that looks like on a graph. We'll get later on to, and we'll touch briefly on what that looks like on an equation. But we're mostly going to be, for now, just looking at what does that look like on a graph. So has everyone got that written down? And then I will do a quick example. And I'm going to do an example that looks like the equations that you guys have been doing in Desmos. Here's my graph. And mine is just y equals the square root of x. So when I'm looking at the graph, what I'm thinking about is, if I look at all the points on the graph, which of those points, what are the x values of those points? So one way to think about this is to say, well, here's the x values. If I go straight down from every point on the graph, and I'll get out of the way because I know I'm standing right in front of my drawing. If I go straight down from every point on that graph, there's all my x values, my inputs. We're all comfortable that inputs is x. So when I look at this graph, one of the ways to say it is that, well, I see 0, x equals 0, and then there's a point that has x equal to 1, and there's a point that has x equal to 2, and there's a point that has x equal to 3, and it's got all the decimal values in between those, which means that my domain for this particular one is everything from 0 on up. There's my minimum is 0. What's my maximum? How far does that graph go off to the right? Any thoughts? Forever. To infinity. And beyond. And because we're dealing with x values, all my x values have to be between those two numbers. Write this down, Jace? Cool, man. Is 0 included on this one? Can I take the square root of 0? What number squared, what number multiplied by itself is equal to 0?
0.
0. So, in fact, yeah, that's included. We'll talk a little bit more later on about the inequalities and how to write them. But one way to think about writing domain is that this is the minimum possible value of x has to be less than x, which has to be less than the maximum possible value of x. And sometimes there's equals and sometimes there's not. We have to sort of think about that. We'll go into more depth about this, but you've seen this before way back when. Algebra. This is just a quick refresher. Now, let's very quickly think about the equation. What kinds of numbers can you square root? Let's let everybody think about this for a second. What kind of numbers can you square root? Talk to your partner. You might also think about what kind of numbers can't you square root. See what we got, Oscar? What kind of numbers can you square root? What kind of numbers can't you square root? What kind of numbers, if you saw somebody written on a piece of paper, the square root of some number that you would look at and go, wait, you can't do that. What do those look like? Ideas? No? Blake? 2 or piece?
No, peace.
What can't you square root? What would you look at if Oscar said, hey, what's the square root of this number? What would it have to look like for you to say, oh, you can't square root that number, Oscar? Lots of numbers? What do they all have in common though? Gracie, what kind of numbers can't you take the square root of? Okay, what's the square root of negative 9, Gracie? But 3 times 3 is positive 9. What can't you take the square root of? Negatives. Guys, remember that? You can't find the square root of a negative because the definition of square root is what number squared equals. But when you square something, it always turns positive, does it not? So yeah, you can't square root negative numbers. Which means what can you square root? Positive numbers. What's the domain of the square root of x? Oh, look. Positive numbers. You can't input a negative number into a square root, so it's not in the domain. Again, just basic refresher, basic example. Cool? All right, let's look at range. We got just time to finish up range. All possible output values. To an equation. Or I guess this would be from an equation. Because it's coming out. Output is which letter? Y values. Let me get a different color here. So let's look at each of the points on this graph. There's a point on the graph. It has a Y value. There's a point on the graph. It has a Y value. There's a point on the graph. It has a Y value. This one has a Y value. That one has a Y value. All those Y values are the range of this function. What numbers can you get out? Remember the pop machine problem from last week? Input was push one of the buttons. Output was what do you get? Well, if you think about it, the domain of that machine was a Coke button, an orange button, and a grape button. Agreed? There's only 3 buttons that we were using. So the domain inputs was Coke, orange, grape. The range, what kind of pop do you get out? A Coke, an orange, a grape. Remember what the other one was? A Dr. Pepper, remember, because the machine wasn't working properly. So the domain was the 3 buttons you could push. The range is the 4 kinds of pop you could get out of it, or you might get out of it. So when we look at range, we just say, oh, look, it starts here at 0 and it goes up to infinity. Starts at a minimum and goes up to a maximum. Tomorrow, I'm going to have you go back into Desmos and we're going to you'll figure out the domain and range of your equations. And then we're going to do a little bit of some other stuff to do the stuff that we were going to do yesterday. All right, pack it up. And if you have a computer at home,
Yeah, just the back.
you should be able to go onto, Google Classroom from that computer, just walk in using the stuff I gave you. And that'll let you get it homework or something, okay? Don't worry about the ones before today. I'll just catch up on those. I'll just watch it. Cool. Oh, syllabus. Bottom tray in this inbox right here. Very bottom tray. I just need the back page, the signed page. I don't need the whole thing. Please tear it off. I don't want the whole thing. Did you get a syllabus?
He said,
That was what you yourself with. Yeah. Michael's trying to say something. The only thing he was doing.
All right, guys, have a great day. See you tomorrow. Just the back page, please. Not the whole thing. In Phoenix, I got an email in. When we found your login, I'll let them know that works. I got an email in to find out where to get your Chromebook. I think they might have just run out of them. And I know that the tech guys probably got more, but they didn't run out in the office. But I did give you one. So. All right. Have a good evening. Yeah.
Tell me why we leave each other not spending our feelings. what's going on.
All right.
Over here. How's it going?
It's going peachy.
Is it? Is today just one of those good days?
Although, fun story.
You said you had to leave at 3, right? Today?
Yeah, but I'm not. Well, I want to go work out,
Okay, yeah, that's cool.
and so yeah.
I'll just go back to the same place I went last time.
Okay, but yeah, I mean, you can hang out for the next bit.
Yeah, I didn't really have questions last night. I understood most of it. It's just the part of getting it done. And then tonight I'm going to my cousin's house to get like final like tutor help with it. So then should all be done by tonight or tomorrow.
Cool.
Thumbs up? Sounds good. See ya.
Okay. Holy moly. That was stupid. All right. All right.
I've seen it too. But he's saying it's been like that or something. Yeah. So,
Okay, domain and range. Not quite sure what these words mean. When you're studying the topic of functions, then the purpose of this video is to get you to understand the domain and range a little better.
the domain, you want to think about what are the possible x values, like what can x be? So when you think domain, think x. When you think range, think y. What can y values be? So for this one, when I do the domain, what I usually do is I take a vertical line, kind of like this marker I have here. What I do is I scan from left to right, because x controls the horizontal, the left and right direction. I scan across, and I see like what can x be. So when I'm over here, can x be negative? No. See how there's not any points on the graph? Can x be 0? No. Can it be 1? No. Can it be 2? No. Can it be 3? Yes. Or to the right of 3. Now when you go to the right of 3, that's greater than 3. And so what we have here is x is greater than or equal to 3. That's the domain. Okay. Now, another way to write this, if you're learning about interval notation, is you can write it like this: 3 to positive infinity. So probably at this stage you're working with the inequality notation, but I'll show you both. Okay, now the next thing is to look at the range, the y values. So when I look at the y values, I take a horizontal line with my marker right here, and I scan from low to high, because remember the y equals the vertical direction, up and down. So when I think of the range, I'm thinking of what can y be? Now, can y be -5 down here? And you can see this graph gradually keeps going down, down, down. So it looks like, there's points on the graph down here, there's points on the graph over here, there's points when y is 0, there's points when y is 1, there's points when y is 2. When I get above 2, see how there's not any points on the graph? So the range is going to be y has to be less than or equal to 2. Now you can see this is a solid point here. If this was open, then it would just be y is less than but not equal to 2, but it's solid, it includes 2 and below. So when you think about going down, that's less than, up, that's greater than, or when you're thinking about the domain left and right, the x values, left is less than and right is greater than. Okay, so that's example number 1. Example number 2, see if you can figure this one out. So the domain, D, okay, I'm just writing D for domain. What can x be? So what I do is, again, I take a vertical line. Okay, I scan left and right because I'm looking at what the x values can be. The reason I take a vertical line is because I want to see that it crosses the graph. So you can see it's not crossing the graph here, it's not crossing the graph here, only until I get to x is -2 or to the left of that. So when I go to the left of that, I'm thinking less than. So here the domain is x is less than or equal to -2, or -2 or less. Now if you want to do the interval notation, this would be from -infinity all the way up to -2, including -2. Probably at this stage, you're just working with the inequality notation. If you want to see more about the interval notation, I have a video on that. You can check that out on the channel, my next video. But let's look at the range now. So the range is the y values. Again, I take a horizontal line and I scan from low to high. Remember, the y is controlling the vertical direction. That's the range. So when I scan, you can see down here, this graph keeps going down, down, down. But when I get up to this point here, there's not any points up here, right? So it looks like the y values are from 1 or below. So that means the range is y is less than or equal to 1. Okay, last example. See if you can figure this one out. The domain, those are the x values. What can x be? Can x be negative? No. Can x be 0? No. Can x be 1? Yes. Can it be to the right of 1? Yes, right? Because there's points on the graph that when x is 1 or greater. So that's x is greater than or equal to 1. And when we do the range, the y values, we take our horizontal line and scan from low to high. Can y be down here? Sure, there's a point of the graph. This keeps going down, 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 right? Can y be here at 0? Sure. Can be 1, 2, and it keeps going up, up, up. So here you can see the range, the y values can actually go from all the way from -infinity to positive infinity, and we would just say that it's all real numbers. Okay, like that. You can abbreviate, we can use this fancy symbol here for all real numbers, or if you're using the interval notation, you can say from -infinity to infinity. So I hope that helps you understand how to work with domain and range given a graph. Subscribe to the channel, check out some more math theory videos on Mario's Math Theory YouTube channel, and I look forward to seeing you in future videos. I'll talk to you soon.